This question gives us the reaction 2 moles of NO gas plus 2 moles of H2 gas are in equilibrium with N2 gas and 2 H2Os. It then tells us that we've got a mixture of 0.1 moles of NO, 0.05 moles of H2, and 0.1 moles of water. That's interesting. And we've thrown it in a 1 liter vessel at a certain temperature. It then goes to equilibrium. It informs us that at equilibrium the number of moles of NO is equal to 0.062 molar, so the concentration is. And then it asks us to calculate the equilibrium constants for the remaining substances. The way we do this, of course, is going to require us to do an ice table. So I'll go ahead and write ice. Remember that I is the initial concentration, C is the change in concentrations, and E is the equilibrium concentration. Now, because these were thrown in a 1 liter vessel, in order to determine their concentrations, all I have to do is take the number of moles and divide it by the number of liters, and I get moles per liter. That's easy to do because the number of liters is 1. So I take this number and divide it by 1, and I get 0.1 molar, and then I get the same thing for each of these substances. So this is the equilibrium, or sorry, this is the initial concentration. It tells us in this problem that, well, it doesn't tell us, but it doesn't say that any N2 was added, so I'm going to assume that the initial concentration of N2 was 0. Now some changes undergo as this goes back and forth in order to reach equilibrium. Then once it does reach equilibrium, I've got a concentration of NO of 0.062 molar. So what I'm going to begin by doing is determining what the change is. What's the difference between 0.1 and 0.062? What I'm going to do is, of course, take the final 0.062 and subtract from it the initial, which is 0.1. That gives me a final answer of negative 0.038. So that is the change in concentration for my NO. It, of course, wants me to fill in the blanks for all of these substances as well. How do I go about doing that? Once I have this change, I can now use the stoichiometry to fill in these blanks. Because I have 2 moles of NO, and I also have 2 moles of H2. So what change has to have occurred in H2? Well, these are the same number of moles, so it's going to be the same change stoichiometrically. I also have the same number of moles of H2O, but keep in mind H2O is a product, so these guys disappear while this one appears. So I'm going to write down plus 0.038. Now what of the N2? Well, if I go ahead and write down 0.038 molar equivalents of either of these, I'll go ahead and write down NO. Stoichiometrically, I'll go ahead and write down molar NO, my apologies. I can write down molar NO in the denominator, I can write down molars of N2 in the numerator. What are the stoichiometric coefficients in front of these? I've got a 2 in front of the NO and I've got a 1 in front of the N2. These cancel each other out, and I'm left with my final answer as being half that, which is going to be 0.019. So I'm going to have a plus 0.019 in this column for my change in N2. Now to get the equilibrium concentrations, all I have to do is do the math. 0.05 subtract 0.038 is going to be 0.012. 0 plus 0.019 is going to be 0.019 as my final equilibrium concentration. 0.1, 0.038 is going to be equal to 0. So those are my final equilibrium concentrations for each of these substances. The next half of this question asks us to calculate Kc. Kc is going to be equal to the equilibrium concentrations of my products, H2O squared multiplied by the concentration of N2 to the first power, then divided by the individual concentrations of my NO squared multiplied by the concentration of my H2 squared. I have my equilibrium concentrations right here on this row. I throw them into the respective places, punch it in my calculator, and I should get the correct answer.